Hey everybody, it's Jenny from Norman S. Wright. We're going to do something a little different this week. Last week I was out at our new Hayward Training Center and I met with John Gardner, our Norman Wright Hydronics Product Manager, and Sean Skiles, General Manager of Fulton, and we talked about the new zero emissions hybrid heating system. So instead of me drawing it out this week, we're going to hear from the product experts. Let's get started. Sean and John will cover some of this, but I want to bring up the image at the bottom of the graphic that'll be behind them to show you the parts of the system before we go over to them to talk about the system. The idea behind the new zero emissions hybrid heating system is to take different technologies and combine them all into one simplified prepackaged hydronic solution that can be skidded and supplied from a single source. It's pre-piped and pre-wired. So let's start on the left of this image. What we're looking at here is single point power. That would mean that all the equipment that you see here, from the pumps to the boiler to the heat pumps and even the controls, are powered through a single connection to the building. And then we have a plant controller that is used to control the pumps and their variable speed drives and to stage the equipment. It's using intelligent staging to bring on the electric boiler only when it's needed in order to satisfy the set point. The buffer tank is used to smooth out the operation and act basically as a thermal flywheel so that as temperature fluctuations occur, the buffer tank will help smooth that out. The electric boiler is here to offer high turnaround capabilities and higher water temperature set points up to 180 degrees. Electric boilers are very compact and simple. There's not a lot of access needed for maintenance, so it doesn't take up a lot of space. Then the air source heat pumps will carry the base load of the system. So with that, I'll kick it over to John so they can tell us more about the system and why we're so excited about it.
So as we move away from natural gas heating in California, most systems are moving towards an air source heat pump strategy for decarbonization. The problem is there's some limitations with air source heat pumps. The energy efficiency is much higher. But what we've seen is that utilizing a hybrid approach with electric resistance boilers provides a lot of safeties, and taking one manufacturer of the electric boiler and then also a different manufacturer of the air source heat pump is kind of what we've been struggling with it and how to coordinate the controls of those two. So we've been working with Fulton in the last couple of months to develop a strategy about how to integrate these two components with the hydronics into a full package product. John, do you want to expand on that at all?
Yeah, it's always a challenge when you take equipment that has its own control platform and its own purpose, and you want to try to marry it up with something else. And so, Fulton over the years has done this with many products, and it only made sense that when Norman S. Wright approached just about using air source heat pumps, how we could build on what we've done already with our control platforms.
So a couple of things that this actually helps with is one problem that building engineers face is a footprint issue. Air source heat pumps are very large in comparison to their heating output. So an electric boiler provides a much smaller footprint. It also provides some protections for either low ambient or high ambient operation of the air source heat pumps, they can be a limitation for how they function for heating a building.
Yeah, and one of the other challenges that we see with this move away from natural gas is existing facilities not having the infrastructure to be able to support those higher amp capacities or higher electric loads that are required if you were just to go from a gas boiler to, say, a electric boiler. So the unique part about this system is because we're utilizing the air source heat pumps with perhaps even a smaller electric boiler, and then we're optimizing the control. We can reduce the required electrical infrastructure, which makes it easier for folks to put those systems in.
The other interesting thing about using an electric resistance boilers in a partial capacity, Title 24 does allow, and it's prescriptive standards for up to 25% of your total heating load of the system to use electric resistance boilers to cover your heating load. And the reason why that is okay to use for an energy efficiency standard is that most buildings don't hit your design load every day. It's going to be a couple of days a year that you're going to need the design days for maximum heating capacity. So on those days, you're going to be at the coldest temperatures. And so the CFP of an air source heat pump is going to start getting lower and lower. And so that difference of what you would get out of a heat pump versus an electric resistance boiler, the delta is much smaller. So you're really not seeing building performance issues very much. And you're getting a lot of resilience out of your system with this kind of backup electric resistance boiler.
Yeah, and in fact, this graphic shows quite nicely what John's talking about, the shoulder loads, if you will, those times of the year when we really need the additional heat. And it's really a very small amount of the year that we need that. The other challenge that, especially in California, that users face or owners face is the utility companies, many of them have demand charges baked into your utility expense. And so if you hit a certain peak load at a given time of the day, you could potentially pay a much larger per kilowatt charge for the balance of that billing period. So with the fact that we have shoulder loads, we have those times where we really don't need that additional heat, and an optimized control, we can even dial in and really control and stay away from those peak load times, which can reduce the overall operating expenses.
The other good thing is that utilizing these prepackaged systems with Fulton and electric resistance boilers and all the hydronic products and skid that goes with it, we can provide single point electrical. It's integrated controls that are going to cover both the air source heat pump and the electric boiler. We will be able to size the flows and buffer tanks adequately for the system. And it's also interchangeable for most manufacturers of air source heat pumps. So we're able to control those things pretty effectively.
And that control, as John mentioned, will give us all the points that building owners need to be able to take into their BMS system and be able to monitor and trend, do all the things that they typically do.
Okay, cool. Thank you.